Hello friends, in this video we are going to study the effect of location of Q point on the output of the BJT. So we know that Q point is a stable operating point, or it is also known as DC biasing point, quiescent point, and it is a point of the DC load line. And we know that DC load line is drawn on the output characteristics of the common emitter configuration. So in common emitter configuration, output characteristics is the graph of output current on y-axis versus output voltage on x-axis at constant values of input current. So I'll show here the output characteristics of common emitter configuration first. So here we are having the output characteristics of common emitter configuration. The output current is IC in milliampere. The output voltage is VC in volt, and here I can draw the different characteristics of the output characteristics of this common emitter configuration for different values of input current. Here the input current is IB. So the first characteristic is for IB1, that is say IB0, then IB2, IB3, IB4. So these are the different characteristics which are drawn on the output characteristics for the common emitter configuration for different values of IBs. This is IB1, IB2, IB3, IB4, IB5, and from IB1 to IB5 there is increase in the base current. With increase in base current there is increase in the collector current. So I am not showing here any values of current, base current, or the collector current, or the here the VC. I'll just denote here that it is say IB1, this is say IB2, and this is say IB3. Now if I consider the 3 points, the DC load line, it is having two extreme points. So this is first point on y-axis and second point on x-axis. The coordinates of these points are VC is 0 and the maximum value of the current IC is VCC by RC, which is saturation current, and the coordinates of this point, which is on x axis, the x coordinate is VCC while the y coordinate is 0. So this is the value of VC for cutoff region. For cutoff region, VC is equal to VCC. Now if I draw a DC load line, it is the point which is joining, it is a line which is joining these 2 points, extreme points. Now if I consider the Q point, which is exactly at the middle of this DC load line, say this is the Q point which is exactly at the middle of this DC load line, and if I consider that if I give AC input as an input to the base terminal, which will swing above and below the Q point value. So this Q point, it will have corresponding DC value of base current, it will have corresponding DC value of collector current, and corresponding DC value of VC, and above and below that the input output will change. Now let us consider this Q point which is corresponding to the IB2. So here this value of base current is nothing but IB2. If I consider that Q point location is exactly at the middle, and if my input is changing above and below this Q point, so here I can show the base current which is swinging above its Q point, above and below its Q point value. So here it is say the base current, Q point base current, and above which it is the AC current is changing. Now corresponding to this point, I will have change in the collector current, right? So this is the change in the collector current, right? So if I consider initially there is increase in the base current, so that is why there is increase in the collector current also, and there is decrease in the collector current. So this is nothing but the variation in the collector current, this is variation in base current. Small b indicates AC current, capital B indicates DC base current. Similarly, small c indicates the AC collector current, and capital C indicates the DC, that is Q point value of the collector current. And if I consider the change in the output voltage, that is Vc, so I'll get the change in the output voltage. So here I am having the axis. Now if I consider with increase in base current, the collector current is increasing, but there is decrease in the collector to emitter voltage. So this is the increase in the value of Vc. So I can show here the VCE, which is say AC, and its DC value is VCE, which is corresponding to Q point. I will say this is Q point, say this is Q point. So with increase in base current, there is increase in collector current, but there is decrease in the Vc, because in common emitter configuration, if I apply the Kirchhoff's voltage law to the output loop, it is IC is equal to VCC minus Vc by RC. So RC and VCC as a constant. So if you increase the collector current, then Vc will decrease. There is inverse relation. So I'll get the 180 degree phase shifted output. So if I consider this positive half cycle of the base current, I'll get the positive half cycle of the collector current, but the output Vc is negative. So that is why here there is 180 degree phase shift between input and output in case of the common emitter configuration. Now if this Q point is exactly in the middle region, in active region, and if input is small, I am getting the complete swing of collector current, complete swing of the output voltage Vc. There is no clipping. Now just imagine if you increase this input, though the Q point is at the center, but if you increase this input, there will be limitation in the increase of the collector current. Collector current cannot go below 0. It cannot go beyond its saturation level, that is VCC by RC. Right? Similarly, there is limitation on increase, two limits of this Vc. The maximum value of VCC is VCC here, and the minimum value is Vc. So though the location of Q point is at the center, and if I increase the base current, what will happen? This collector current will try to increase, but it cannot go beyond VCC by RC and below 0. So that is why you will get clipping, distortion in the collector current, and similarly there will be distortions in the Vc. So that is why if the Q point is at the center, you will get the complete output. Transistor will act as an amplifier, but this input should be small. If it is very large, what will happen? You will get clippings or distortions in the output. So that is the problem. Now let us see the effect of the location of Q point. If this Q point is near to the saturation region or cutoff region, we'll see that. I'll draw again these characteristics. Now friends, we'll study the effect of Q point on the output if Q point is near to the cutoff region. So cutoff region means near to the horizontal axis, that is Vc axis. So again I'll draw the output characteristics of common emitter configuration. These are nothing but the collector characteristics curves. So here I am having the x-axis Vc in volt and the output current Ic in the milliampere, and I can show here the different characteristics for different values of Ib. So here I am having the first characteristics say for Ib1, second characteristics for say Ib2, third characteristics for Ib3, then for Ib4, then Ib5 likewise, right? Now I can show here from the Ib1 to Ib2, Ib3, Ib5 there is increase in the base current, so collector current will also increase. Here there are two extreme points of this DC load line. The first point is on the y-axis, which is A, whose coordinates are x is 0 and y is VCC by RC, and the B point, which is on x-axis, whose coordinates are VCC comma 0. So if I join these 2 points, I'll get a DC load line. Now let us consider we are having a Q point and whose location is near to the x-axis, that is it is in cutoff region. So if I consider the Q point is here, right? So I'll get the corresponding value of base current corresponding to the Q point, right, which is DC value, which is corresponding to the Q point. So it is IBQ. Now what will happen if I give the AC input, right, which is swinging above and below the Q point. So what will happen, corresponding to this, I'll get the 2 points, upper limit point and the lower limit point on DC load line, So this bottom side point, it is below the VC axis. Now if I take the projections of this on the collector current axis, so this will be the first point, then this is the point corresponding with the Q point value, and then I'll get the third point which will be below this VC, right? Now if I show the collector current, AC collector current, it will swing above and below the DC value, that is Q point value, and I should get such swing, complete swing. But there is one problem here. We have seen that the value of VC, it cannot go below 0, and if I consider this collector current, right, it cannot go below 0. So that is why if I consider this portion below IC is equal to 0, this portion of collector current, it will be clipped off, right? It is nothing but the distortion or the clipping. So this portion will be clipped, and I will not get this portion. And if you consider the waveform, resultant waveform, I'll get only this part of the collector current waveform. Similarly, if I show the variations in the output voltage, I can take the projections, right? So here, corresponding to Q point value, I am having this point, say this is VCQ, right? And this is the change in output voltage VC. So here I'll take the projections from this point and this point, right? So what will happen here, I should get such output, complete swing output, but there is one problem. The VC value cannot exceed the VCC, right? That is B point. So that is why I'll again get here the clippings in the output. I'll get the clippings in the output. So the actual output will be only this part. So this is the problem when the Q point location is near to the cutoff region. Similarly, if Q point location is near to the saturation region, what will happen? The upper part of the collector current waveform will be clipped, and here the one of the cycle, some part of that cycle of VC will be also clipped. So this is the effect of location of Q point on the output of BJT. When Q point is exactly at the middle, you will get complete swing in the output. There is no distortion if the input is small. If input is big, both upper and lower part of the complete cycle will be clipped. If Q point is near to the cutoff region, then you will getting clipping in one of the half cycle of the output, and again if it is in saturation region, you will get the clipping in one of the part of the output. So that's the effect of location of Q point on the output of BJT. Thank you.